Dear students and my dear fellow viewers, I welcome you all in this lecture. In today's lecture, I am going to discuss with you the spherical lenses. As I was discussing with you the phenomenon of refraction of light, the refraction of light takes place through transparent substances. So far, we have discussed the refraction of light. We have discussed the laws of refraction with respect to glass slab, that's the transparent substances. We have also discussed the refractive index and related numericals. Now, in today's lecture, let's try to understand what are spherical lenses. Dear students, spherical lenses, they are the transparent material bound by two surfaces, of which one or both surfaces are spherical, they form a lens. So simply we can say that a transparent material which is bound by the two surfaces, जिसकी दो surface होती हैं. So either of the surface या दोनों surfaces they are spherical and they form a lens. So यहाँ पर आपको अच्छी तरह याद है, it's not a mirror, it's a spherical lens. So lens is a transparent substance, while as mirror is a, we can say that's not a transparent substance, that is a reflecting substance. Now we have got two types of lenses. We have got two types of lenses. One is called convex lens and second is called concave lens. This is the convex lens and this is the concave lens. Now look at these two diagrams. This convex lens, this is bulging outwards, बाहर की तरफ ये निकला होता है, and this is here bulging inwards, अंदर की तरफ inwards. So this convex lens is also known as converging lens, while as this concave lens is also known as diverging lens. This is known as converging because it converges a parallel beam of light passing through it. Similarly, this is known as diverging lens because it diverges a parallel beam of light passing through it. Okay, so after refraction, it converges. Similarly, after refraction, this lens diverges. That's why this is called diverging and this is called a converging lens. Dear students, convex lens is thicker in the middle and thinner at the edges. It is thicker in the middle. बीच में ये thicker होता है, मोटा होता है, लेकिन as per its edges are concerned, they are thinner. Concave is its opposite. Concave lens is thinner in the middle. So this is thinner in the middle and thicker at the edges. Now, some basic terms related to spherical lenses. You look at the diagram here. This is here a convex lens and this is here a straight line passing through the center of this lens, or we can say the optical center, which is known as principal axis. Okay, so this is focus and this is also a focus. A lens has two foci on either side of it. Similarly, this is a concave lens, center principal axis, center of curvature, focus. Okay, now the terms that are associated with these lenses, they are like here optical center. Optical center, the point on the principal axis at the center of a lens is called its optical center. So what's optical center? Basically optical center, optical center is the center point of the lens, यानी जो lens का center point होता है, that's termed as optical center. The point on the principal axis at the center of a lens, or we can say it is that point through which the principal axis passes. So this is a point on the principal axis at the center of the lens, or simply the center of the lens. The center of the lens, center of the lens जो होता है ना, यानी जो central point of the lens, that's called its optical center. वो मैं आपको यहाँ diagram के थ्रू दिखाना चाहूँगा. This point, this very point here, this is here termed it as optical center. The center point of the lens, the center point of the lens. You got it here? Now, center of curvature, as you are well aware about the center of curvature with respect to spherical mirrors. Similarly, a lens has two spherical surfaces. These two spherical surfaces, they form a part of a surface, and the center of these spheres is known as center of curvature. So it is here similar with, as compared to, we can say in the same way as the spherical mirrors. So the center of these spheres, as the lens has two surfaces, these two spherical surfaces, they form a part of the sphere, and the center of these spheres is known as center of curvature. One more term that's associated with these spherical lenses, that's here principal axis. The principal axis is a line passing through the center of curvature and the pole of the lens. Now, pole of the lens, you know that this is one surface of the lens, this is second surface of the lens. This very surface, the center point of the surface, the middle of the surface is pole of the lens. So simply a straight line, and imagine that passing through the optical center, or we can say that passing through the pole of the lens and its center of curvature. You got it here? Both lenses and spherical mirrors, they are having the center of curvature. So what's principal axis? It's a line passing through the center of curvature and the pole of the lens, or we can say a straight line passing through the center of curvature and the optical center of the lens. One more term that's associated with it, that's aperture. Aperture means size. What is the size of the lens? Okay, the size of the lens suitable for refraction, that's called its aperture. As in case of mirrors, you know the size of the mirror, that's called its aperture. And focus, as you are aware that folks, it's a point on the principal axis on which the light rays parallel to the axis they converge or diverge after refraction. So that very point जहाँ से light rays converge होती है या diverge होती है after refraction from the mirror, that very point is here called as focus. So one more term that's associated with these lenses, that's power of a lens. What's power of a lens? Dear students, power of a lens is its converging or diverging capability of a lens. It's called its power. The converging or diverging capability of a lens is called its power. In how much light it converges or how much light it diverges after passing through it, after refraction of the light through it, that's called its power. So it is given by the reciprocal of its focal length and its power. Oh, sorry, and its unit is dioptry. We will discuss it in the further in the lecture that's coming, inshallah. Now you got here the concept of spherical lenses. So uh, what are the basic terms that are related to it? So it's now clear to you. We have to go through the image formation by these spherical lenses, as we discussed the image formation with the help of free diagrams in case of spherical mirrors. Similarly, these spherical lenses, they also form the images. So we need to understand what type of images they form and what are the rules that are associated with the image formation of these lenses. You got it here? So similarly, we have to take the object on the principal axis on either side of the lens. As it's a lens, so they are different from the we can say the mirrors. So here the refraction of light takes place, while as in case of mirrors, the reflection of light was taking place. So inshallah, in the next, or we can say in the coming lectures, I'm going to discuss with you the image formation with the help of ray diagrams and the rules that are associated with these spherical lenses. In today's lecture, I gave you the concept, the basic concept about spherical lenses. What are spherical lenses, how they look, okay, what is their difference, that's convex and concave lens, and what are the terms, like optical center, like principal axis, like focus, like center of curvature. uh, so both these are, we can say, the power of the lenses. So I think you have got this basic concept regarding the spherical lenses in this lecture. Inshallah, I will meet with you in the next lecture. Till then, Allah Hafiz.